Hi everyone. This lecture 16 is about combining couples with different planes. So here we go. I'll first discuss the principles. So the couples, especially if their axes are in different planes, perpendicular to the different planes, is best combined by representing or transforming them into their rectangular components. So so that we can easily add corresponding components, the x, the y, and the z components. So it is better to represent couples using the double header, remember, arrow, because the double arrow points the right thumb and the curling of our forefingers represents the sense or the direction or sense of that couple. So for example, the following are couples C sub 1, C sub 2, and C sub 3 with associated components. So let's express each of them in rectangular form, then find the resultant couple. So for C sub 1, you have to curl your forefingers. You notice that your right thumb will be pointing towards the positive x-axis. So in vector form, C sub 1 is 200i. Then couple 2 is on this blue plane here. Then the direction of the couple is along the plane. So it looks like that. That's the direction or the sense. So if you follow the curling of your four fingers, then your right thumb perpendicular to the plane where couple 2 is acting is directed in in that direction in that direction. So the x component is negative while the y component is positive. Then lastly, in other words, this couple 2 has only two components, the x and the y components. And finally, this couple 3, so it is on this plane EDA. Then if you curl your four fingers in the same manner as this, then the axis of the couple will be perpendicular to this plane, and so it is pointing in that direction, and it has uh, negative x component opposite to x, positive y component, of course, then positive z component. So to do that, we first define the axis of the couple, then after that we can compute or we can express that couple into its rectangular components. So this third couple has XYZ component. So this is the first couple. It is 200i in Newton meter in vector form. Then for couple 2, it is perpendicular to the plane DABO. So if this is the orientation, this is the X, the Y, then the Z, there's no Z component. The Z axis is pointing as our view direction, opposite to our view direction. So the z-axis pointing towards us. So this is 5 meters, and this is the plane where the couple is belonging to. And therefore, if you follow this curling, then the double arrow will be perpendicular to this plane and it is pointing in that direction. So that's why the x component is negative and the y component is positive. So that's the couple, double header, is perpendicular to this plane. So if I call this theta 2, then the angle it makes with the vertical is also theta 2. So that shows that the x component is negative and the y component is positive. So for the x component, it is sine of theta 2. So sine theta 2 is opposite 3 over 5 sine theta 2. So C sub 2 therefore is 300 times for x component, it is opposite of theta 2 is 3. So negative 3, then adjacent of theta 2, so pointing upward, the y component is, so adjacent of theta 2 here is 4. So that's it. So negative 3i plus 4j divided by magnitude of this vector, so square root of 3 squared plus 4 squared. So C sub 2 is negative 200 is negative 180I plus 240J Newton meter. Then axis of C sub 3. So the axis of C sub 3 is derived by either, there are three possible ways. One is uh, cross C, that we get the cross product of dA, position vector dA with dE. Then it is also equal to RAE, curl your, position your four fingers in that direction, then curl it towards dA, then that's the direction. Your right thumb will be perpendicular to the plane and it is pointing in that direction. And lastly, RED, so your four fingers will be pointing here, curl it towards EA, curl it towards EA, then definitely your right thumb will be pointing in that direction, perpendicular to that plane. So you may try to evaluate these three cross products. I will only present one, but you may try the cross products, the rest of the cross products. You will notice that the results will be the same. So axis of couple 3 is RDA cross RDE. So DA is positive 4, then positive 3. 4I plus 3J. So 0 along Z or K. Then for DE, it is pointing backward and upward. So 0I, positive 3J, negative 5K. So 0, positive 3, negative 5. And copy the elements of the first two columns and unit vectors ijk. So for I, it is 3 times negative 5 times I, so negative 15I minus 0, because 3 times 0 is 0. So negative 15I. Then for J, 0 minus negative 5 times 4, so 20J. Negative 15I plus 20J. Then for K, 12, 4 times 3 times K, 12 minus 0. So it is negative 15I, then plus 20J, then plus 12K. So therefore, we can now express co couple 3 is equal to 400 times the unit vectors of this result. So it is equal to negative 15I plus 20J plus 12K. This is another uh, derivation of the axis of couple 3. So we use REA cross RED, where AE is negative 4I, 0J, then negative 5K. So negative 4, 0, negative 5. Copy the first two column elements. Then for AD, A to D, that's negative 4I, then negative 3J, then 0K. So negative 4, negative 3, 0. Copy the first two column elements. So if we expand, so we have 0I, then minus negative 3 times negative 5. So that's negative 15I. Then for J, negative 5 times negative 4 is positive 20J, and minus 0. Then for K, negative 4, negative 3 is positive 12K, and 0, minus 0. So it's the same, negative 15I plus 20J plus 12K. So finally, we can now express couple 3 into its rectangular components of magnitude of the couple, then unit vectors of that cross product or axis, unit vector of its axis. So it is equal to negative 216.4I plus 288.5J plus 173.1K Newton meter. So we can now combine the resultant couple would be, you add the corresponding x components, so 200, negative 180, then negative 216.4 I, then we have 240 J, then plus 288.5 K, then 173.1k. So there's no other k component. So the magnitude for the resultant couple in vector form is -2 is equal to that shown. So that's the answer. Okay, let's proceed to example 16.1. So determine the resultant couple for the system of couples shown in the figure. So this is the given figure. So we have this couple here. This is the axis of the couple. Is about 360 Newton meter in magnitude. So you point your right thumb towards this direction of the double arrow. Couple 2 is on this plane AEH, and it is rotated in that sense. And couple 3 is on plane KAC, and it is rotated in that sense. The sense is in that direction. So for couple 1, express it into its rectangular components. So it is magnitude times the quantity -2i, then -3k divided by the magnitude of that direction, square root of 2 square plus 3 square. So couple 1 is equal to -199.7i plus 299.5k Newton meter. Then couple 2, since this is in this sense, so we have to compute the or define the axis of this couple. So it is directed in perpendicular to this plane, but the double arrow is at the back of this pointer. The back of this pointer. So it should be, we have to cross the following vectors: RHE cross REH. So your right tab will be pointing opposite to this plane, or REA cross REH. And finally, it may also be REH cross RAE. So your right thumb will be in the opposite direction. So axis of couple 2 would be RHE, as I said, cross RHA, or REH, REA cross REH. So it is in the opposite sense. And we have REH cross REA. So your four fingers will be there, and you curl it towards this vector here, AE. Then your right thumb will be perpendicular to this plane, but in the opposite direction. So this is the positive direction. The opposite direction is on the opposite side. Then let's just define RHE cross RHA. Then you also define this to make sure that the axis is the same in vector form. So HE is positive 5i, then 0j, then positive 4k. So positive 5, so 5, 0, 4, then for HA is 0i, then negative 3j going down, then positive 4k. So 0, negative 3, 4, copy the first two column elements, then unit vectors. So for I, it's 0 times 4, I 0, then minus negative 3 times 4, so 12i. For j, is 4 times 0, 0, then minus 4 times 5, negative 20j. For k, negative 15k, minus 0, so negative 15k. So C2 therefore is magnitude times the axis vector unit vector of the axis vector. So we divide it by the magnitude of the axis vector. So C sub 2 is equal to 103.9i minus 173.1j minus 129.8k. Then for column for couple C sub 3, so if you cross CK with CE, the sense of the curling of your four fingers will be the same, and your right thumb will be pointing in that direction. So cross CK with CE or EC with EK, the sense is the same. The curling of our four fingers will be the same. And KE cross KC. So axis of column couple 3 is RCK cross RCE, or equal to this cross product, but I'll just present CK cross CE. So CK is negative 5i, then positive 3j, then 0k, so negative 530, negative 53. For CE, it is 0i, then it is upward, so positive 3j, so 3, then positive 7, so in this direction, so 7k. So copy the first two column elements, then the unit vectors. So for I, 3 times 7 minus 0, so 21i. Then j, 0 minus negative 35, so positive 35j. For k, negative 15 minus 0, so negative 15k. So therefore, couple 3 is equal to magnitude of the couple times the axis vector, unit axis vector divided by the magnitude of the axis vector, or simply the product of the magnitude and the unit vector of the axis. So couple 3 is 193.2i plus 321.9j minus 138.0k. So combining like terms, so the resultant couple would be negative 199.7, then plus 103.9 plus 193.2i. For j, 0 quantity, then negative 173.1, then plus 321.9j, and for k, 299.5 minus 129.8 minus 138. So this is for j, then for k, 299.5 minus 129.8 and minus 138. So simplifying, this is the resultant couple, 94.7i plus 148.8j plus 31.7k Newton meter. So that's for example 16. So for example 16.2, determine the resultant couple for the system of couples shown in the figure. The couples have magnitudes C sub 1 300 Newton meter, C sub 2 400 Newton meter, and C sub 3 600 Newton meter. Also compute the direction angles of the resultant couple. So we are given this pictorial view so that we have couple 1 on the top surface, horizontal surface. Couple 2 is on the surface of this blue plane. And couple 3 is there on the rear. So sense is like that, but we are provided with another figure for us to clearly see it. So couple 1, you position you curl your four fingers in this manner, then your right thumb will be pointing upward. So couple 1 is simply in vector form 300j. Couple 2, because this is the sense of curling, so it will be pointing perpendicular to this plane, but not in this direction, but in the opposite direction. Try to curl your four fingers and it will be in this opposite direction. So that's why it's clear in this figure here. This is the plane, the blue plane, supposedly. Then for this third couple, so it is now clear here that we have to curl our four fingers in this manner. So that's why our right thumb will be pointing perpendicular to this plane and in that direction. So it is now clear here. So these angles are given 50 degrees, 60 degrees, 60 degrees. So the angle that couple 2 makes with the vertical is also 50 degrees. So couple 1 is 300j positive in vector form. So this is also 50 degrees. That's one. So the y component is c sub 2 cosine 50, negative, downward. Then the z component is going right, so opposite to the z axis, it's also negative. It is magnitude of couple to sine of 50. So this is also the angle that the couple tree, which is perpendicular to this plane, is making an angle with a vertical of 60 degrees also. So couple tree has y component, which is positive, then z component, which is negative. So couple 2 is magnitude times negative cosine of 50, j, then negative sine, because this is going to the right, sine of 50 k Newton meter. Then couple 3 has positive y component, so it is magnitude of couple 3 cosine of 60 going up. So 600 quantity cosine of 60 degrees parallel to y, so j. Then the z component is going rightward, which is opposite to this positive direction. So it is negative magnitude 600, then sine of 60, negative sine 60 degrees k Newton meter. So simplifying, it is 300j minus 519.6k. So we can now combine the corresponding components. There's no I component, so let's begin with j, 300, then negative 257.1, then plus 300 again. J, sorry. Then plus for K, we have negative 306.4 and negative 519.6. So combining like terms, we have the resultant couple in vector form 342.9J minus 826K Newton meter. Since we are also required to determine the direction angles, so we use the direction cosines formula. Cosine theta x is cx over magnitude of c sub r. So let's solve magnitude of c sub r. It is square root of 342.9 square plus 826 square. So magnitude is 894.3. So cosine of theta x equals 0 over 894.3. So theta x is 90 degrees. Inverse cosine of 0 is 90 degrees. So cosine theta y is equal to CY, which is 342.9 divided by 894.3. So inverse cosine of 342.9 over 894.3 is equal to 67.45 degrees. Then finally, cosine of theta z is negative 826 over 894.3. So theta z is more than 90. It is equal to 157.5 degrees. So those are the direction angles. Then this is the resultant couple in vector form. Then for our last example, example 16.3, given the set of forces and a couple of 1,200 Newton meter in the diagonal plane ADFG, compute the moment, number one, about the x-axis, the y-axis, the z-axis. Also compute the magnitude of the resultant couple about the origin, which is denoted by F here, this figure. So all are parallel forces. Then we have this couple here on this plane ADFA, ADGFA. Then if you curl your four fingers, then your right thumb will be perpendicular to the plane ADGF, and it is in that direction. So if we position ourselves on the positive x-axis so that we can clearly define or transform the 1,200 Newton meter couple into its y and z components. So this is we are now on the x-axis, positive x-axis. So this is the z-axis, the y-axis, positive direction. So this is 4.2, 3.6. This is the plane of the couple, and the couple is perpendicular to this and is pointing in that direction. If you follow the right thumb rule by following the curling of this couple here, so it will be opposite, so in that direction. So that's the couple perpendicular to this plane. Then if I call this angle theta, then the angle that this couple vector direction mixed with the vertical is also theta. So that if we express that couple into its components, so we have the y and z components only, wherein the y is positive and the z component is negative. So for the y component, it is magnitude times course cosine of theta. It is adjacent. Cosine theta from this figure is 3.6 over square root of 3.6 square plus 4.2 square. So 1,200 times 3.6. Then for the z component, because it is in that direction rightward, this is the positive z direction. So it is sine of theta. And sine theta is 4.2. Opposite in this right triangle here, the opposite is 4.2. The hypotenuse is square root of 3.6 square plus 4.2 square again. So which is this? These are the component directions. So simplifying, so we have 780.95 J minus 911.11 K Newton meter. So the rest of these parallel forces can be easily evaluated their moment about X, Y, and Z. So for these forces here, parallel to the Y-axis, they don't have moment about the Y-axis. So only about X and about Z-axis. So moment about X, so we have this couple here has no x component, so by right thumb rule, 1000 is positive, 800 is negative. They have the same moment arm 3.6. So it is quantity 1000 minus 800 times 3.6. So this is the right thumb rule. That's the sense of positive moment about the x-axis. So quantity 1000 minus 800 times 3.6. So it is 720 Newton meter. Then moment about y is 0 for these vertical forces here. But we have y component 780.95 from the couple. So it is 780.95 Newton meter. And moment about z-axis, this is the z-axis. We have component of the couple negative 911.11. Then 200, the moment of this 200 force is positive. Follow the right thumb rule. So that's the positive sense. So minus 1000 times 2.5. So it is quantity 200 minus 1000 times 2.5, then plus negative 911.11. So that's the moment about the z-axis. So minus 911.11. So moment about z-axis is negative 2911.11 Newton meter. And finally, the magnitude of the resultant couple is simply the square root of 720 square plus 780.95 square plus 2911.11 square. So the magnitude of F is 3098.85 Newton meter. So to show that the couple is really represented by this, so you may also define the axis of this 1200 Newton couple by getting the cross product of GF, your forefingers towards GF, curl it towards GD. So that's your right thumb will be pointing this direction. So GF, curl your forefingers. GF, this is the direction of your forefingers, curl it towards GD, then your right thumb will be pointing that direction. So let's do that. Axis of the couple, 1200 Newton couple. So its axis is crossing GF with GD, where GF is negative 2.5i and GD is 4.2J plus 3.6K. So, or negative 2.500 for GF, then for GD, it's 4.20x, 4.2y, then 3.6z. For 0i, 4.2j, 3.6k. And copy the first two column elements, then the unit vectors. So for I, we have 0, then 0. So there's no really x component, 0i. For j, we have 0 minus 3.6 times negative 2.5. So that's positive 9 at j. And for k, negative 2.5 times 4.2 is negative 10.5, then minus 0, so that's 0, so negative 2.5. So the couple is now equal to its magnitude times the unit vector of its axis. So 9j minus 10.5 over square root of 9 squared plus 10.5 squared. This is the magnitude of the couple. So if you simplify that, this is the same as this uh, couple representation. But these are the answers. I'm just showing you another way of expressing that couple into rectangular form. So that's it. I hope that it's clear here the combination of couples into one, known as the resultant. So the double arrow header will be used in defining the components of the couple because it's much easier. So you just scroll your four fingers in the same manner as the given couple, where it is lying on that plane, then your right thumb will define the axis of that couple. So thank you for watching, and I hope that you learned from my lecture series. I hope that this series can help you in your preparations to become future professional civil engineers. But take note that my lecture series are also intended for other allied engineering courses. So if it is your first time in my YouTube channel, then don't forget to subscribe and like. If you want to have comments, then do it. Thank you and God bless.